Welcome to Smart Software with Smart Logic, a podcast where we talk about new and emerging technologies in the field of web and mobile software development. My name is Justin Siepin, and I'll be your host today. I'm a developer at Smart Logic, a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. I'm joined today by my colleague and co-host, the infamous wizard, Eric Ostrich.
Hello, everybody.
Great. And Eric, can you maybe tell us a little bit why this episode is a very special episode in comparison to our usual?
Yeah, so this episode we recorded the Saturday at lunch of Lonestar ElixirConf 2019.
What did we talk about in this episode? Because we definitely hit a lot of topics, but it's definitely worth listening to.
So we kind of talked about Elixir.next, kind of what's coming in that, releases in the core, numerical computation performance, a lot about that, Big O of Elixir, language wars, and the challenges of adopting Elixir in your workplace.
So we somehow managed to get probably the 10 most important developers in the ecosystem all in one room. Kind of a big deal. So give it a listen. Here is the Lonestar ElixirConf 2019 Lunchisode. We are at Lonestar Elixir 2019, sitting in the green room with a number of the speakers and keynote speakers that are here for this conference. I'm going to let them go around and introduce themselves. And we're jumping in right now. What's up, Amy?
Oh, sorry.
No.
Chris just messaged me and told me to come.
Yeah, come on in. So we've also got the crew from Elixir Outlaws here. We've got Chris Keithley, we've got Amos King, we've got Chris McCord, we've got Jose Valim, we've got Paul Schoenfelder, and we've got some more. And we'll all introduce ourselves. Chris Keithley, do you want to take it off since you're in the corner right by the mic?
Yeah, sure. So I'm Chris Keithley. I don't know what I'm known for. Probably like maps versus structs is the thing I'm most popular for right now. And just being a resident curmudgeon, I guess. I didn't really mean to end up that way, but here we are. And yeah, I run a podcast with Amos and do open source stuff and yeah, more or less just like say things in the community. I don't know. What do you guys laughing? This is so awkward. What do I do? I don't do anything. I just talk to people.
I mean, yeah, you're right. Raft implementation, just small.
Yeah, I wrote Raft once. Yeah, I wrote Raft once. Yeah.
Chris.
Things like that. Yeah, I wrote Phoenix, so that's my main. No, so yeah.
I mean, no big deal. I wrote, but I did write.
Yeah. I think we can be a little bit more enthusiastic about that.
Yeah. So yeah, I wrote this web framework called Phoenix. Yeah, so Phoenix is probably obviously my main contribution to the community. And I somehow parlayed that into working on Phoenix and related libraries almost full time at Dockyard. So I found myself getting paid to write open source, which wasn't the original goal, but has worked out pretty well. So it's been kind of crazy being involved in the community since like 2013 when we were just doing the best we could. Yeah, we're getting
Don't
old.
count the days.
Yeah. You know, at the beginning, we were just trying to get anyone to just listen to us and try the library and language out. I remember being in IRC, watching like the active users, like, oh, we got like 18 people today. And, last week we usually see like 10. So anyway, it's been pretty cool to see the community grow and people start using Phoenix, and somehow I find myself with a large user base and companies using it, so it's been a pretty cool ride so far, and yeah, happy to be part of it.
Very cool. And feel free to shamelessly plug anything you want. Paul?
Yeah, I kind of came to the community, I think, not long after these guys just like came from .NET, mostly working in enterprise hell, and started writing libraries for things I was interested in, like that's why I ended up building EXRM and Distillery, Timex, later like libcluster and some of those other things. There's a handful of libraries I've written for different things. Combine, yeah. It's nothing now though with Nimble Parsec. But yeah, a lot of those libraries, and just kind of have fun finding problems I want to solve and writing open source. Like Chris, I work for Dockyard. They pay me to basically work on open source all the time. So that's what I find myself doing, and just trying to do that for as long as I possibly can, and keep contributing to Elixir and to Erlang, and try and keep things moving forward to bigger and better things.
Great. Amos?
I do the podcast with Keithley. I've done quite a bit of nerves work over the years. Library called Grove Pi for people who are really just starting out with hardware using Grove Pi system. Worked on Shoehorn, the crazy Shoehorn thing. As Keithley shakes his head at me, this is how it normally goes. I pretend that I know what I'm talking about, and Keithley, actually is me, and shows me how I'm wrong. But
That's
it
not
works
true.
out well.
That's also how our podcast works, where Eric makes sure I'm not a total idiot.
Yeah, we edit it all so it sounds like I know what I'm talking about, but really, Chris just keeps me in line. I guess that's about it.
Great. And the reason we're all here, Jim?
So I know Chris. That's why I'm here. I know Chris. So
It's an inside joke, but yeah. He does know me.
I thought you were talking about me.
Oh.
Yeah.
Oh,
wow.
Jeez, McCord, don't get ahead of yourself.
Golly, man. Just everything's always about you.
Which one of us is the other Chris?
Oh, snap.
No, I mean 100%. I'm the other Chris. Like, let's
I met
not be coy.
Mr. McCord for the first time on IRSSI, right? So he was talking about Phoenix over sugar.
There were a few options.
A few things were trying to crop up at the time, right?
Spinach,
So,
sugar, thunder.
yeah.
Wait, there was something, a project named Thunder?
Yeah. Remember?
I don't even remember that.
Darko. He joined. He was the first Phoenix core team member. But he
Oh, yeah, I remember that.
disappeared very quickly.
Oh my
But
God,
yeah,
this
he wrote the first. He helped with the first project generator.
is amazing.
Yeah.
I tried to
Fun
use.
times.
I told him I would really wish I could use Phoenix, but it was like only like a week old. but I couldn't do it. But so my contribution
Report
is
did, so.
I started
Bleacher Report's
the
like-
first
When was
ElixirConf here in Austin, Texas, and this is our fourth. 2, 3, 4. This is
Wait.
our fifth
Yeah.
conference here in Austin. I started the Elixir.
No, 6, no? The first one was 2014. So
Well, we
this
had
is-
the two main Elixir conferences, and this is our third Lonestar.
So you skipped the year at some point.
Well,
So
Well, you
Lonestar.
get
14,
14,
15,
15,
17,
18,
18, 19.
This is number 3 for Lonestar.
It's because ElixirConf was here, right?
Right.
And so it starts to blend in as though like that was. Lonestar,
Yeah. So
right?
we had ElixirConf here 14 and 15.
Yes, that's 2. And then
Yes.
this is the third ElixirConf.
Yeah,
So
so
2
you had
plus 3.
17, 16, 19. You skipped 16.
So 2 plus 3 is 5.
Yeah. You skipped a year.
Okay.
And so anyway, I started ElixirConf EU, and our first one was in Krakow, where Jose is. And then I helped start ElixirConf Mexico. And then I started Lonestar ElixirConf. So,
After you skipped a year.
yeah, here.
Zaki's in the corner working on his talk
Yeah.
that he's about to give. Do you want to introduce yourself?
Hmm?
Do you want to introduce yourself?
Yeah. I'm practicing.
So no.
Okay.
Yes.
And the man himself, Jose Valim.
Hi, I'm Jose. I'm the creator of Elixir, co-founder of Platform Tech. Yeah.
Great.
And then I'm Eric. Mostly do silly text games. So yeah.
Great. So I think we should start with Jose and hear, partly what was the impetus behind Elixir. I know we've all heard that before, but now, where's it going? Where's the future?
Oh, the future. That's great because I was looking for an excuse to delegate the question to all of you. And the future is in the community, so your turn. But speaking seriously, At my last ElixirConf keynote, I talked exactly about that. Like Elixir is a programming language, like the things you want to have in the programming language. We are mostly done, so the next thing we're doing is exactly releases, bringing a minimum set of features so we can have release as part of core. And after that, I'm on permanent holidays, and it is really up to the community to continue extending Elixir, bring it up to new domains, and tackling new challenges.
So releases just came up in that answer, and I guess Paul, you can really talk about where we stand with the releases and where we're going.
Jose's kind of taken, the general concepts that were in EXRM and Distillery and, made it part of Mix. I don't know that that's been released yet, but that's in progress, I think. Planning for the next major release.
Yeah, we're out in July.
Yeah.
According to our every 6 months release.
So yeah, that would be the first time that releases would be part of core, and it would be like the fundamental primitives, right? It's not the full feature set that Distillery has, and that's intentional. The idea is that the community provides those extensions and additional features. Distillery would be one of those libraries. My aim is to essentially rip out the parts that will now be in core, and then just act as kind of a library on top of things to provide some of the things that don't really belong in core but are nice to haves anyways. This past year, when I was working on Distillery, it was mostly about figuring out, how are we going to deal with the question of runtime configuration and just how do we get that last mile on the features we need to really make this part core. I think Jose was really helpful in helping me work through that, and we came up with the config provider stuff, and that seems like the right abstraction for this, but it remains to be seen, once we've got stuff actually in Mix, how it works out. I think, we've seen with Distillery, a lot of people have been really happy with the 2.0 release and, how much easier it is to use versus how it used to be. And I hope that, with it in core, it becomes even easier and there's just less friction. People always expect that deployment to some degree is solved by the language itself. In some languages it's just kind of a given because you're compiling to a static binary or something, but it's a little bit different in Elixir because we're kind of this blend of, interpreter based, but also doing some form of ahead of time compilation. So it's a little bit confusing that you don't get some artifact that you can then run right off the bat. But with releases in core, I think it'll feel more like that, more like there's a native solution to deployment, and that should help people feel like there's less of this pain in the process. Especially back when EXRM was kind of the primary tool, there was a lot of edge cases and things that didn't work particularly well, a lot of areas where it wasn't very flexible. And that was the main reason for rewriting it into Distillery, was to provide more extension points and things like that. But there's still lessons learned even in Distillery. So now that we've kind of iterated through a lot of those different pain periods, I think Mix has got the right abstraction.
Excuse me. Did you mention about the compiler on of Elixir? Yeah.
Yeah, I mentioned the compiler.
Yeah. I'm developing the compiler of Elixir. This is Haste is a part of compiler. This compiler. So I use meta programming infrastructure of Elixir that utilize to parser as parser. Yeah. So and backend is will be implemented to as LLVM. So my today is my presentation introduce this architecture of this compiler.
Yeah.
Yeah.
Awesome.
Oh, yeah. Yes.
Was you were working on a compiler to leverage the GPU, right? Like,
Yes. Yes. Not only GPU.
Yeah, that's cool.
Now I developed a focus on GPU and SIMD instruction, but not only them, but also all of computation on Elixir.
Okay.
Yeah, I mean those kind of efforts I think are important because particularly being able to leverage the GPU for things like vector calculations or heavy math will enable us to kind of close the gap with performance on the beam's weakest point, which is really
It will
raw
there would
computation.
be an answer to the unsubstantiated adage about number crunching,
Right. Yeah.
which is like, which is like true, but also like no one has any measurements. So it would be nice to say, oh yeah, if you need to do this number crunching, we actually have a great option for that.
Yeah, thank you.
Solved, done.
Can you expand on that a little bit?
It's,
Oh, you do? Okay.
yeah, so I think is we inherited that from Erlang. So and from old Erlang, because it's not a problem in Erlang anymore. So the issue is that Erlang would be slow with number crunching, and when we say slow, it's not like we are comparing to C, we are comparing to Fortran, compared to Java.
Yes.
We're not comparing with PHP.
Yeah.
I'm not dissing on PHP. Just saying that in benchmarks, it's one that comes.
My
Right?
vision includes this vision.
Yeah.
Yes.
Right. So
Yes.
and so it is low if you're going to compare with those languages, but when this was everybody talked about it was before we had nifs.
Yeah.
So Erlang improved by adding nifs, which is a way that you can run native code like C in the Erlang virtual machine. But that was still a problem because even if you have nifs, the nifs they could not block, they could not hold, they could not stay they could not run for a second because that would mess up the scheduler in the virtual machine, how the virtual machine works. So 2 years ago, actually it started on Erlang 17, which is kind of like 4 or 5 years ago. They started experimenting with this thing called dirty nif, so I can say, look, I have to perform a task, it's going to take a really long time, and just let me do this. So now we have, when we're talking about number crunching, right? So a language that a lot of people use for number crunching, like Python, right? You're not doing that in Python, you're integrating with C. Is that before Erlang and Elixir did not even have this option to integrate with C. So today we have the option to be on pair with the other languages, given the fact that all those languages they are mostly doing C integration, and that's a possibility today. So so number crunching is an issue, but today it can be solved as you would solve it in any other platform.
There's also high performance Erlang. If you compile the native, like it's got an LLVM backend or a regular GCC based backend, and that gives you something. It's like in between nifs and just raw Erlang Elixir code because you're compiling to machine code, but you're not running the risk of interfering with the scheduler, right? Like that was the main thing with nifs is that it's still, even with dirty nifs, it's possible if you're not writing the nif correctly to break things, kill the node, that sort of thing. But I don't think Hy-V is particularly used too often, or people aren't necessarily aware of it. But
right. So the thing about hype, hype is a way you can say, I want to compile this code to native, and it goes there to your Erlang Elixir code. It's going to compile that to native, but with built-in integration in the VM, it uses the same memory model and everything. The issue with hype is that, so for example, if you run the Elixir, you want to compile the Elixir with hype because it's going to run 3-4 times faster. So it can really be an improvement, but you need to make sure that you are compiling a closed part of your code base.
Yeah.
You do not want to be jumping between hype compile code, not hype compile
crossing
code.
the barrier is really expensive.
So for example, if you say I have so if it's I have this numerical computation where everything is expressed like this, and then say, look, I want to compile everything here and everything that this calls to native, then Hype is going to give you a improvement. And then so I was just coming from Code Bean San Francisco, and they announced that they're also going to make the JIT compiler. They're going to make it open source. They have been researching it for a while, and they'll make it open source. There is still no kind of deadline when that thing is actually going to be usable, but they are making at least one step in this direction. So a lot of exciting work happening on the area.
Yeah.
I also think though, like, and I mean, I'm super excited about all that. It's going to be awesome. I also think that it's funny when people comment on, you know, the Beam being slow, and those are the same people who are like running web services, and they're like, I want to run web services that like do all this I/O work, and just it's very funny to me because there's so few pieces of that problem that are truly CPU bound, and they're all bound by like networks. And more than anything, in my opinion, at really high scales, you're bound by failure. Like you're bound by like faults, and you're bound by faults in the system and how you handle those faults in the system. And it doesn't sort of matter that the Beam is slow, even if you took the line of reasoning that it is slow, like computationally, like just does less CPU than Java does or whatever. Because like you're able to handle faults so much better and run all these things concurrently and like isolate failures everywhere. And so I don't know, like when I look at our metrics and like see our traffic spikes and stuff, it's like I couldn't imagine trying to do any of this with Java. Like I've worked on big systems with Java running at scale. It's like this is a nightmare. I got to pay like 3 people to learn how garbage collection works and to swap it out with some other improved thing and to like tune JVM heap sizes, and I don't want to do any of that crap. Like, anyhow, we barely do any tweaking of the Beam to get performance out of our system.
Right out of the box, it's really well.
Did you mention the isolation of memory space?
Mm-hmm.
Yeah. I agree strongly because ARM VM is very strong memory protection. So ARM and Elixir can
use leverage.
Yeah. So, but now NIF means native interface function is not. I think not. This is not called invoke new process of ARM VM. So the in NIF cannot multi-process programming. So Haskell is can't multiple programming. So this now current implementation is using POSIX thread or Rust thread, but this has some overhead. So I want to use RMVM process, but I can't.
Mm-hmm.
I see.
Mm-hmm.
And I also think with the number crunching, and I'm in the web space obviously, so I don't go too low level, but the number crunching thing also pressures me a little bit, because when people use that as a way to dismiss Elixir, or like, this is audio recording, but we keep mentioning slow, but it's like in air quotes, so you don't see. So imagine the air quotes. It's like slow in the context of like compared to C, but faster than probably anything most people are using. But the thing with number crunching specifically for me is, and someone could correct me if I'm wrong, but is this a true statement? I can represent, if I'm trying to represent the largest integer possible, that the Beam would exhaust system memory.
Yeah.
Versus overflowing.
Theoretically.
So for me, I think the conversation around this too, like people, they just see, oh well, it's slower than C or it's slower than Java, but the
the nuance is like what Chris was talking about. Was for one, at least coming from the context of what I think a lot of us in the community are building, like it doesn't matter at all. But for two, like there's a trade-off there where like we don't have to worry about the specific data types like overflowing.
Yeah, don't have to worry about the different kinds of
and
integers.
And there's legitimate reasons for that. Like when you look at Erlang and the problems they were solving, like if you want a system that's up and running for months or years, like you don't have to worry about like if I'm bumping some counter reference, like oh well I ran this for 8 months and it crashed because I overflowed an integer. It's like there are valid reasons to some of this number crunching being quote unquote slower, but it's not like oh just we didn't get it right. It's like there are legitimate reasons they are the way that they are. So you're getting benefits from the potential downsides that most people, and that conversation, that side of it never happens.
And I like there are like some things in the Erlang docs because from this scenario, like they have to think about running it long term. Is like, oh no, we add this functionality, and then that, for example, is allocating like unique references, right? And then they're like, well, we have this functionality implemented in a way that if we call it every like second, you're going to get a duplicate. Like they did the math and they put in the doc. Like you're going to get a duplicate in the year 2300 and something. I'm glad you did the math. I'm glad you're safe.
Well, I think a lot of people end up too like using a lot of really just bad logic to reason about this kind of stuff. And it comes up with like with the immutable data stuff too, where people say, well, because I can't do. I mean, you talked about this yesterday in your talk. I meant as I gestured to Osa,
which is a great opportunity to introduce the guest that just joined us. Osa, Gaius, do you want to introduce yourself and talk a little bit about your history of Elixir?
Yeah, sure. I'm Osa Gaius. I worked at several places doing functional programming. Joined a company called Luma. We built lots of consumer devices, and I faced a similar challenge like they were describing here, where by 5 Elixir engineers, sort of like a sort of conflict within the company, and the answer to that by management was to bring in 2 Java developers to rewrite the entire piece of software. And I thought that was interesting because their argument was Elixir is slow, even though we had reached 50,000 devices in the field. But I think they were able to make the argument because we as Elixir developers at the company didn't have a strong stance on why saying something is slow is intellectually bankrupt as an idea, and saying that writing in Java was also equally silly, right? We couldn't say that because we weren't bold enough, but I think they as Java developers were bold enough to say no, your language is silly and it's a toy language. So I think there's definitely a
no one's ever been fired for choosing Java, right?
Right. Yeah.
So I think part of the challenge, at least for me in that moment, was being pretty strongly opinionated about why slow doesn't matter and why Java wasn't the right answer in that situation, especially given a complete rewrite. But I think that's kind of tough when you're in the moment.
Well, I also think slow is not the things that people do even when they try to be scientific about what slow means is just wrong. They're just not correct. People talk about with immutable data not being able to do O1 access to things. And it's well, it turns out you don't know how to. It turns out that 1 doesn't matter in practice because log 32 is pretty good, and also you need to learn how amortized time complexity works. And Amos will tell you all about that.
Don't look at me.
So,
tired of reading that book.
Yeah, I mean, but I just mean that amortized time is actually how new data structures are being created, and those are where interesting advancements are happening. And this whole swath of people doesn't know how to do that.
Even in OO languages,
right.
Amortized time is something that
matters. Researchers
are looking at way more often than they used to.
Yeah, but it's easy to sort of chalk up and be nah, it's too slow. It's just a bunch of lists.
Could you define that in simple terms for?
No.
There's a book.
No, amortized time just means so traditional big O notation is based on this thing called asymptotic time analysis, and the idea is that you look at the worst case scenario. Where probably people are familiar with that. Amortized time analysis basically says, well, it turns out that the worst case isn't always the worst case. The worst case isn't what you do a lot of the time. And so instead, you do time analysis based on the number of based on the types of operations that you would actually do to a real data structure, right? So I'm getting and I'm setting, and those increase costs and decrease costs. And I can actually do a more interesting time analysis based on the distribution of operations that I'm going to do on a piece of data. And so it turns out that when you do that, it opens up this whole design space for much more interesting data structures. And that's where you start to get things like hash rate map tries. Like, there's a lineage there that traces all the way back to like Chris Okasaki's book and doing immutable pure data structures. And sort of works its way down to where we are now, where we get to utilize all this stuff. And it's because it opened up the design space to talk about more interesting ways of mutating and changing data, and more interesting ways of doing analysis. And yet, most of us don't ever learn that unless you take a master's, degree or you study it on your own. And so we're still stuck in a way of looking at the design space when actually a lot of the design space has changed when you talk about academia. So, I don't know, there's that too. It's like people are still using old ways of thinking about problems.
Well, and if slow to you is about CPU, but your problem is not CPU bound, then it's irrelevant. Doesn't matter how slow it is.
But my Fibonacci as a service is gonna be dope.
Better write that in Rust.
Right? Yeah, you gotta write it in Rust. Those types will really solve it.
I've run assembler instead of Rust.
I've run into it a few times where arguments of people saying, well, Elixir or Lang are slow, and even doing mathematical computations, a lot of that stuff, if you sit down and try to break it down, you can parallelize it pretty easily. And I brought that up, and I've been told, oh, well, we can do that too. And then I have it parallelized and faster because I can parallelize it in less than a day,
yeah,
and they're still working on it 2 weeks later and frustrated and can't get things working. So to me, it was worth that amount of time to move on to the next problem. And I'm already faster than their current solution, and they're still working on the next one to try to parallelize that.
And without data points and the nuance, then the conversation is, there's no value to it. Like just as far as number crunching, like I said, I'm not doing any like matrix computations, but like one of the projects that we've worked on recently is like a financial trading platform. And instead of immediately saying like, oh, we better shell out to something that can do number crunching, we started with like, what are your, we asked the client, what are the trading requirements? Like, what's the max throughput this thing needs to handle? And we were told 10,000 trades a second. So it was like, well, let's see what we can do in Elixir and see if we can get 10,000 trades a second. So we wrote a trading algorithm. So long story short, like using Ecto, getting the data in the system with Postgres, and then reacting to that event, walking a couple EDS tables and doing the actual trade matching logic just in Elixir, comparing Elixir structs and data structures. So it's not really hard number crunching, but something that you would say for a financial trading platform, comparing all this data. Anyway, we were able to get 13,000 trades a second on our development MacBooks to validate, like, is Elixir good fit
on the
for this?
first try, or pretty much like the implementation as it came to be? Or
Yeah, as it came to be. I mean,
yeah.
there wasn't really any massaging. It was like, okay, get the data into the system, persist it, build it in EDS, and then we would walk a couple EDS tables and match trades and then move data around. Load it up with work, run the benchmark, 13,000 trades a second. Like it's, so that's how when I hear number crunching, yeah, at first it needs to be nuanced. Like, what are you doing, and then what do you mean by number crunching, and given this metric that you're trying to achieve, it may be like for us that was blazing fast. So we were like, okay, great, this works on a MacBook, then let's build this product. And we didn't even have to go down the rabbit hole of let's write a NIF for this.
Yeah. I mean, we've certainly seen CPU problems. Like I won't, it is something to address. Like it is a real thing that you do need to be aware of, and certainly like at Bleach Report, we've seen CPU bound problems mainly around JSON decoding and encoding.
Yeah,
so,
I mean, like,
but
if you can make it
surmountable.
faster, why
It's
don't
surmountable.
you make it faster, right?
Right. Yeah.
I think everyone in this room, if you say like, I will make it 10 times faster, nobody's going to say no. Everybody's going to say yes. Right?
Yeah,
Like, nobody's like, no, I don't want that. I mean, unless you have issues like, I saw that somebody tweeted that they had to add a slowdown in their application because
I retweeted it.
it was replying so fast that people they would
thought it was fake.
thought
Their
was not.
customers thought they were faking the UI.
Yeah.
Like they didn't believe it.
Anyway, but
That
going
seems
back.
like a good tweet that made. I don't buy it. I don't
No.
believe that.
Gotta slow it down to make it
I have
enterprise.
a vision, one vision. My Haskell will only not only server side and client side, and also client side. So via WebAssembly and WebGL and WebGPU. Yeah. So client side computing just using for user interface and machine learning on user side. So and server side computing will use database manipulation and some cloud computing. This is my vision. Yeah.
So we've got about 10 minutes left, and I want to shift gears from some of the real deep technical topics that we've touched on. And Jose, I'll let you go there. But I want to talk, because Osa, yesterday in your talk, you brought up how Java in the 90s won the language wars, and how that was not the outcome that was actually best for the community. I'd like to hear from you guys. I mean, how do we, and I think, and maybe part of this is being pretty aggressive about it, how do we take back the mantle? How do we displace the top dog and sort of rectify this error in the marketplace? I think.
Yeah. Just a second. I just want to finish the thought.
Sure.
So, so like we would all take a performance speed, right? Like everything can be 10 times faster, right? But the goal is that, the point is that performance in the huge majority of the cases, it's like salary, right? Like who would like here at a 10 times raising salary? Everybody's like, yes, please, right? And no one say no. But we as engineers is like, we want to receive a reasonable amount of salary, so we can focus on our work. We don't have to worry about things. The same thing with performance. You want to have a good ballpark where you can do everything, and then you can focus on everything else, right? So assuming that performance is good, is in a good place, then you're going to value everything else. You're going to value fault tolerance. You're going to value the programmer productivity, happiness. You're going to value the tooling. Right? So in the most cases, the performance is in the good ballpark. And yes, and there are things that can improve, right? So for example, in a web application, I think what could be improved with performance? It's like JSON. JSON code deploy. That's something that could improve. But even things like in other languages, in other frameworks would be a problem, like template rendering. Template rendering is a problem-solving thing. There's nothing to speed up there. It's go as fast as it can. And so like in an application, I see possibly encoding the code is very good in performance, and to maybe get something that's going to be 3 times faster than what we are right now, and then to me, like if I would say why I would want things personally to be faster, is just to make the compiler even go even faster. That for me, that's that. I want, to me, if I can get a 10 times faster compiler, to be that, to be about the tooling. But I think like most cases, the performance is totally fine, going to be totally fine, and you can look at everything else. Yeah, sorry, I had to.
No, I think that's interesting, right? Because I think if we assume that performance is already good or good enough, I think then the real question is, how do I, as an engineer, convince my manager who manages 10 people to let me spin up this Elixir thing to solve this problem when we already use PHP or Java, right? So I think the real challenge isn't how do we overturn Java or replace Java, whatever phrase you want to use. I think the real question is how do we get a seat at the table so that when we make that decision, it's not, here's this random esoteric language versus here is the best performant language that there are a bunch of libraries for. And I think that's that takes more work on our end than it does from a language level, because I think we have to come to the table with an openness and say, like, what is the Java thing you care about performance for? Like, okay, how many requests per second do you want? How many trays per second do you want? Okay, I'll go build you a system that does that. Let's compare, apples versus apples, rather than, I think today, people assume, that we don't have a sort of an answer to the performance question, and so they sort of automatically dismiss it and say, well, let's just pick something we know is quote unquote performant. So yeah, I don't think it's about winning. I think it's more about getting into the conversation.
But do we think that generally performance is the bottleneck of Elixir adoption?
No,
I don't think it is.
It's
No,
I think it drives the adoption.
So we just had Ben Cardarella walk in the room. We're
Right.
shooting a
Right.
podcast right now, and you're on audio if you want to be. Do you want to maybe answer this question about how does Elixir win the language war and displace Java as top dog?
I don't think it will.
I don't think that's realistic. I don't
Yeah.
think,
Yeah,
I don't think
if
that's
that's
a
the goal-
Sisyphean task.
Yeah, no,
Do we
I'll
care?
be honest. If that's the goal, is to displace Java, I think it's going to. Failure is the only result of that. I think that a more realistic goal for Elixir is to probably aim for like top 3, as opposed to go for number 1. If you go for number 1, like displacing how heavily like Java benefit from the time in which it came up and where systems were being developed from scratch and they assessed what language to use. And now at this point, if you're trying to displace Java, you have to convince those organizations to replace what they currently have, which is significantly more difficult than going in and deciding something from the get-go. So I don't think that's a realistic approach. I think instead, like I said, like top 3 or something like that. But as far as methods for doing so, I mean, like my talk said, it's a more nuanced approach. The performance and the developer ergonomics, these are all good for engineers to discuss with each other. And I think some engineers that have been faced with those problems see the value of that. But there has to be an economical reason that is brought back to non-technical people on why they should adopt this or consider it. And the economical reasons vary from organization to organization. So someone came up to me after my talk and said that they've been interviewing with a bunch of companies and they want to use Elixir in these companies, and they asked me how they can get Elixir to get adopted into those companies. I said, I can't answer that question without understanding what the pain points of those companies are. And maybe in some cases it's not the right answer, but it's, I mean, the specific points that we've seen with difficulty bringing Elixir into companies is talent availability, which I think, so my argument in my presentation about those that are able and willing to transition to Elixir, I think has truth to it. I wouldn't put it in there if I didn't think it was true. But I think that there is just a gap right now between where Elixir is in other languages are in terms of available like high caliber talent. Like, you know, bringing over Rails engineers to doing Phoenix apps is good, but when you start to, you know, when you start to get into more of the weeds of like building out like really like highly concurrent systems and what that takes, that's where like some real training needs to occur. The other side of it is going to be just, you know, a lot of companies are burnt out on being told that they need to now try out this other thing. This has been a consistent problem that we've seen. Like, it used to be that companies like to get ahead of the technology curve to a degree, and they would talk about, or they'd be willing to adopt it because some new engineers came in and said, oh, this is what everyone's doing now, we need to do that. And a lot of companies and a lot of management are wise to that game, and they're sick of it. They're sick of wasting money, they're sick of having their you know, this disruption to their product, their feature development and their products being part of the roadmap now. I think what they're looking for is long-term investment in a particular platform or technology. If they're willing to accept what they currently have, okay. But I know, Jose, you didn't see my talk, but one thing I put in there was at ElixirConf where you spoke about how you have no real plans for 2.0 right now. And I think stability is one of the most appreciated value of what Elixir brings to the table. And it's something that should absolutely be part of the conversation when you know, putting together the values of Elixir into organizations. Like, it has long-term stability. You You can make bets on this technology and not be concerned that like 2 years from now you're gonna have to rewrite everything because some new version, like new APIs are available. Always just like upgrade pains exist in all these. I mean, JavaScript is probably the exact opposite. It's like the other side. Everything's moving so fast in JavaScript that you're constantly upgrading all of your applications, and it's such a it's such a weight on the teams to absorb that.
I've run into a lot in working with clients in that they're not after high concurrency, high availability. Many pieces of software out there don't need to be that. So when you try to sell them that, they also say, well, I don't need an engineer who's good at that stuff. I can hire a mid-level Java developer at a dime a dozen compared to what I have to get somebody who has that skill set to come in and do Elixir and high availability. So being able to show them why high concurrency can help them more than just in the engineering point has been a good way that I've.
It's a bit of a double-edged sword because the things that we get excited about as engineers aren't always the things that other people in Works are excited about. And when we start to really like go off and get into the weeds of talking about these things, we lose them.
Sometimes you lose that argument, like for us.
Like when you're talking about number crunching.
Well, yeah, well that's one thing, but like for us, like I've been involved with stakeholder meetings where I'm pitching Elixir. They're evaluating, and sometimes it just doesn't make sense for them, and I think that's okay. Like in one case, like Amos was saying, the fact that it was fast and scalable, the main things that we used to pitch Elixir, all of the shining points, like they were like no big deal. They literally it's not a direct quote, but they said we were happy to literally throw money at the problem, and they had a lot of Ruby engineers, and they didn't want to retrain them. So the pitch that I could make was not compelling, and I think that's okay in some cases. So I think this is kind of what Brian was saying, like, you're not going to always win. Like, we can't displace everything. Like, I think no matter how good we are, it has to make a business sense, and that's where you have to play to what can it actually do for the company. And for that specific stakeholder, for what they saw could not do much for them. But then, like we were talking at dinner, Chris and I, with someone else at their company, they were paying for like a WebSocket connection provider and they were paying like $10,000 a month. So they were able to go to management and say, I think Elixir could be pretty good here and save us $10,000 a month. And then they spent 1 week of company time and rewrote it with Phoenix, and it works better, and they're not paying $10,000 a month. So it was a easy business decision there, but it had to make sense for the company.
All these things are marketing things, and at the end of the day, marketing is 100% always about picking a competition and then comparing you to the competition. And you don't pick competition that can beat you. You pick competition that you will win against, and then you let people make choices for themselves. And like I think we as a
Visual
group,
Basic.
we as a group have to figure out what it is that we're going to market. Like what is it that's going to like take us to that next level, and like lean into those things, and then just give up or not waste our energy trying to win against things that are always going to be the default choice. Like trying to be like, let's say you wanted to say like replace Rails as the default choice for boot camps, you will fail. You'll just not succeed at doing that because it's already the de facto standard. So you're going into a competition that you're like never gonna win. So like you got to pick your right battles.
Well, we're at time now, guys. This has been an incredible conversation. I've never seen anything like this in a podcast before, so thank you all very much. The fact that like Bruce Tate just walked in here at the last minute.
Hey Bruce.
Bruce. You want to say hi, Bruce?
Hi.
Yeah. It's just wild. I've never seen anything like that. So.
And we have Ben Marx as well.
Yeah,
Ben's
and
over there.
Marx walked in too.
Hello.
So.
How many people can we fit in this room?
It's pretty remarkable. Thank you all so much. This has been an episode of Smart Software with Smart Logic.
With smart people.
We do not have smart water though.
Yeah.